My name is Dr. Sachin Borse. I am currently working as a professor in Department of Mechanical Engineering, Imperial College of Engineering and Research, Pune. Today I will discuss the importance of the GATE exam, and I will also talk about the fluid mechanics and weightage of fluid mechanics for the GATE exam. Let us start with my introduction. My name is Dr. Sachin L. Borse. I have completed Bachelor of Engineering in Mechanical from North Maharashtra University, Jalgaon, Maharashtra in 1998. I qualified the GATE 2000. After graduation, I was in industry for 1 year and then I appeared for GATE exam and cleared the GATE exam. After qualifying the GATE, I joined Master of Engineering program with a scholarship. That time the scholarship was 2,500 per month, and ME Jet Propulsion and Gas Turbine from the MS University Baroda in 2001. Then I again joined teaching, and then thereafter I joined doctorate program, that is a PhD, and I finished PhD in Mechanical Engineering from Thermal Fluid Engineering, IIT Bombay in 2007. I work in the industry as well as teaching. I was associated with KSP pumps in the research and development. I was also associated with Mahindra Steel Company, Pune. I was associated with the Viscosity as a consultant. I have worked in industry and teaching. So I was associated with the Shakra University, in Government University in the Saudi Arabia. Then I was associated with Rajashri Shaw College of Engineering, Pune. Then I was associated with Didi University, Nadia, Gujarat, Rajashri College of Engineering and Management, Pune. I was associated as a visiting faculty in College of Military Engineering, Pune. Baba Saheb Ambedkar Technological University, Lonere. And also I have delivered almost 60 lectures in various workshops at NITs, government colleges. Now let us move to the GATE exam. So GATE is written as GATE in capitals because it is a short form. So GATE stands for Graduate Aptitude Test in Engineering. This test actually tells the government the level of engineering skill students have acquired after finishing this degree. So this exam tests the comprehension and understanding of various undergraduate courses in engineering. This exam is conducted jointly by Indian Institute of Science and 7 in IIT. IIT stands for Indian Institute of Technology. The GATE score is valid for a particular period and it denotes the relative performance of the candidate. Like my GATE rank was around 1,500 in the mechanical engineering student appear for GATE exam in GATE 2000. My percentile that time was 85%, indicating that I was leading the 85% student. Now let us understand the importance of GATE exam. Why we should appear for GATE exam? First thing, By qualifying the GATE exam, we can get admission to the Master of Engineering, Master of Technology program in leading institutes, government colleges, IITs, NITs, and also few foreign universities, including the National University of Singapore. The MTech student get the scholarship of 12,400 per month, and as you are financially not dependent, you earn the scholarship, so you need not to depend on your parents, don't need to create the financial burden on your parents. GATE qualified candidates are also eligible for award of JRS, that is Junior Research Fellowship, in the CSIR laboratories and the projects. Many PhDs have kept the GATE as a criteria for applying the job. We know the public sector unit, public sector companies. You can go to these companies by achieving the highest score in the GATE. And please understand that higher salaries are offered to the postgraduate students as compared to the graduate students. One important thing I will clear here, that the core jobs in your field are offered to the postgraduate student from the premium institute. So for getting the core job, it is the one option to go for post-graduation. And one more thing I will stress here, that GATE score shows your ability, and you can prove to the outside world that even you have finished your degree from average college, but you are at par with the student finish the graduation from premium institute. So I support that every student should appear for GATE and qualify it with a good score. Now let us understand one subject called as the fluid mechanics. So from GATE point of view, what is the weightage of this subject? So about 5 to 7 marks are allotted to the fluid mechanics. Now let us move and understand the subject fluid mechanics. What is the fluid mechanics? Okay. Before going to fluid mechanics, let us understand mechanics. So what is mechanics is? It is a branch of physical science that deals with the bodies, either in the rest or in the motion, with forces. What is the fluid mechanics? So it is the mechanics for the fluids. So fluid mechanics deal with the behavior of the fluid, either at the rest, it defines it as fluid statics, or in the motion, that's fluid dynamics. So question will come in your mind, what is a fluid? So fluid is a substance that will continuously deform under the action of the shear stress. And the shear stress, which is tangential one, applied on the fluid, it deforms continuously. That is called as a fluid. You can see here that tangential force is applied. Okay, so shear stress is the shear force divided by area, but this force is not perpendicular. This is the tangential force. Okay, so after the action of this shear force, there will be continuous deformation. Now when we say fluid, fluid can be gaseous, can be liquid. The applications of the fluid mechanics. I will classify as industrial application, flow through the pipes, with friction losses, minor losses, flow through the channel, open channel flow, flow through pumps, flow through the turbines. This is the industrial application of fluid mechanics. Then shipping, that is design of the ships. Then drag force in the ship. Then design of aeroplanes, helicopters, lift force, drag force. Blood flow in the human body. This is non-Newtonian flow. Now let us understand what is the engineering problem the fluid mechanics is. As a fluid mechanics engineer, our task is to design and size the fluid system. Hence, our purpose is either to estimate the pressure drop in the system or to estimate the fluid flow. So, along with this, the fluid mechanics engineer must be able to calculate the power required to move the fluid by use of external agencies like pumps, compressor, blower and fan. So let us move to the gas and liquid. Liquid is a state of matter in which molecules are relatively free to change their position with respect to each other, but restricted by cohesive forces, so as to maintain relatively fixed volume. So liquid has a fixed volume but no fixed shape. For example, water is a liquid. Now let's move to the gas. A state of matter in which molecules are practically unrestricted by the cohesive forces. So we can see that there is more freedom to the molecules in case of gases. So gas is neither having the definite shape nor volume. For example, air. Now let us move to the properties, fluid properties. We will go to fluid mechanics. We should know the fluid properties. First properties, let us understand what is the meaning of the properties. It is one which gives the physical condition of the fluid. It gives what? Physical condition of the fluid. Now let us see fluid properties. Few properties. First property is density. It is generally indicated by rho. What is density? It is the mass per unit volume. The mass of the fluid divided by the volume of the same fluid. So if you take mass in kg and volume in meter cube, so you get the unit of density as kg per meter cube. So SI unit is kg per meter cube. So this properties are available in property table. It may be given in kg per meter cube or it can be given in gram per centimeter cube. Let us see the various fluids and their density. Let's understand. Higher the density means heavier the fluid is. Like let us see the coconut oil. The density is 920. Density of water 1000. So what happens? The fluid with the higher density will move down, and the fluid with the lesser density will float on it. So whenever there is spillage of coconut oil in the water, it will float on the water. Then density of petrol, it is also less than water, 720. Density of mercury, it is 13,600. It is heavier than water, 13,600 kg per meter cube. So if you compare with the steel, we know that steel is used for welding the ships. Its density is more than water. By giving some particular shape to the ship, you can even use the steel for the volume of the water displaced by the ship. Volume of the water displaced by the ship should be the volume of the fluid which will be displaced by the ship will be less than the volume of the ship, so that it can float. You see also, wood is having the density less than water, so without any proper shape to the wood, we can allow it to the float in the water. The aluminum, if you see aluminum is also heavy, so it cannot float naturally. So properties like densities for various fluids, liquids, chemicals are generally available in the data book, transfer of Mechanies book. For special fluids, there is a website called as matweb.com. You can find the density. You can see here. You can go to this website. You can find densities or properties of any fluid. Now we'll move to the one more property called as weight density. It is denoted by gamma. It is, we can say, it's a weight per unit volume of the fluid. So if you take particular weight of the fluid and you divide the volume of the same fluid, you will get the weight density denoted by gamma. This unit is Newton per meter cube. So instead of kg in the mass density, you have to write down Newton per meter cube. So let us find the relation between the weight density and mass density. For that, we need to apply the Newton's second law of motion. You know that Newton have given the three laws. That's why the mechanics it is called as the Newtonian mechanics. First, the law gives definition of force. Second law gives the equation for the force, and third law gives the nature of force. Here, for applying mathematically, we use second law, which gives the equations. So it gives that force equals mass into acceleration. Okay, so we can write Newton's second law: mass into force is equals to mass into acceleration. Okay, so if you talk mass, so we can write weight is the force, and mass is mass, and acceleration is what? Instead of acceleration, we write acceleration due to gravity, that is the g. So if we divide both the sides by volume, weight divided by volume, that is weight density, and mass divided by volume, that is density. Now let us move to the specific gravity. So what we do in case of specific gravity, we compare the density of the fluid with some reference fluid. For liquid, we take the water as a reference fluid, and for gases, we take air as a reference fluid. So what is the specific gravity E? It is denoted by a letter S. It is the density of the fluid divided by density of the reference fluid. As I mentioned, reference fluid is taken as water. Reference fluid for the air is, for the gases is taken as air. So if the value of specific gravity it is less than 1, means it is a lighter fluid as compared to reference fluid, and if S is greater than 1, means it is a heavier fluid as compared to the reference fluid. Now let us move to the very important property of the fluid called as viscosity. So what viscosity is doing to the fluid is it is creating internal resistance. So the motion. So it is the internal resistance to the fluid flow. It is the fluid property. So it is the shear stress. So if you see the SI unit of viscosity, it is Newton second per meter square. Sometimes this viscosity is also called as the dynamic viscosity, and this viscosity comes from the Newton's law of viscosity. It is constant of proportionality from the Newton's law of viscosity. What it tells, Newton's law of viscosity? It tells that shear stress tau. It tells shear stress tau is proportional to the shear strength, that is the du by dy. And when we want to replace this constant proportionality by some constant, and that constant comes to be mu. That is dynamic viscosity. Let's now take dimension of dynamic viscosity. It is calculated. It comes to be Newton second per meter square. Shear stress, that is Newton per meter square. Shear, that is du. Du means change of velocity, meter per second. Dy means distance, that is meter. So rearrange, you get viscosity as Newton second per meter square. So already I told motion between the plate and the fluid. So it requires velocity of plate u. So velocity varies from 0 to u. So if you remove the proportion of this sign, then we get a constant, and this constant is called as dynamic viscosity. This equation is called as the Newton's law of viscosity. So there are the fluids which naturally occur is the air, water, glycerin, alcohol. This follows this law. So what people earlier thought that this is a universal law. No. The other fluids not necessarily follow the Newton's law of viscosity. Okay, so fluids which follow this law, like water, air, alcohol, glycerin, these are Newtonian fluids. Okay, the fluids which do not follow this law are called as the non-Newtonian fluids. Now there is a science called as the Rheology, which studies how material flow or deform under the action of applied force. So the fluids are classified as ideal fluid, real fluid, Newtonian fluid, non-Newtonian fluid, ideal plastic fluid, or called as Bingham plastic fluid, or thixotropic fluid. So we will see. Ideal fluid means what? So it is an imaginary fluid having no viscosity. So it will not offer any resistance to the flow. Real fluid means what? It will have viscosity. Viscosity is not zero. It is having some value. Viscosity is having some value. Thus, this fluid provides resistance to the flow. Now, we have already seen Newtonian fluid. You see the shear stress on the y-axis and shear strain on the x-axis. You feel that there is a straight line for Newtonian fluid. We have already seen the examples on Newtonian fluid. Now let us move to the non-Newtonian fluid. So here shear stress is not proportional to the shear strain, but it is having some different rule. So shear strain will have some power, okay, denoted by the N. Okay. Now based on the power of this N, if N is less than 1, it is called as pseudoplastic. If N is greater than 1, it is called as dilatant. Dilatant is butter, and pseudoplastic, paper pulp or milk, this is the pseudoplastic. Now let us move to the next category, that is the ideal plastic or Bingham plastic. Here the fluid having the definite yield stress, and thereafter there is a relation, linear relation between shear stress and shear stress. So there is definite some shear stress is required first to cause the flow, like the toothpaste when a lot of force initially, but as it starts flowing, it is very fast. Okay. So we can write the equation here that shear stress is equal to constant plus mu into du by dy. Is shown by the straight line, this ideal Bingham plastic. Next is thixotropic fluid. So here fluid having definite yield strength, but thereafter relation between shear stress and shear strain is not linear. For example, printer ink and lipstick. So these are the isotrophic fluids. So hello. Now we will see the kinematic viscosity, which is denoted by the nu. So it is ratio of dynamic viscosity to the density of the fluid. So kinematic viscosity is given by dynamic viscosity divided by the mass density. So its unit is meter square per second. So mostly kinematic viscosity indicates what is called as diffusion, that is a velocity diffusion. It is indicating the diffusion of the velocity, how fast the velocity will penetrate in the flow. That is indicated by kinematic viscosity. Now let us see how the viscosity changes with the temperature. Please understand here that there is very little change in viscosity with the pressure, but there is appreciable change of the viscosity with the temperature. For the gases, viscosity increases with the temperature, but for the liquid it is opposite. Viscosity decreases with the increase in the temperature. So if you see the viscosities of the liquid are several times higher than that of the gases. You can see in the diagram here, gases, as the temperature increases, the viscosity increases, but for the liquid it is opposite. As the temperature increases, viscosity decreases. Now you can see some viscosities. For air, 1 into 10 raised to minus 5. For water, it is 100 into 10 raised to minus 5. For SA oil, it is, we know that viscosity of oil is very very high, 29,000 into 10 raised to minus 5. So we'll stop here. Thank you.